Hey, I'm going to talk today about L'Hopital's rule. Well, L'Hopital's rule is a way to do limits when you have indeterminate forms. And our different indeterminate forms could be like infinity over infinity, 0 divided by 0, 0 to the 0, infinity to the 0, 1 to the infinity, 0 times infinity, or infinity minus infinity. And if you have any of these forms, then you are allowed to use L'Hopital's rule. However, L'Hopital's rule only works if it's in these two forms, so we will have to do some conversions to move it around. Now, these are considered determinate forms, and here's what they are and what they are equal to. So like infinity plus infinity stays infinity. When you have those, you don't use L'Hopital's rule. What L'Hopital's rule tells us is that if we have a limit as x goes to some number of a function that's being divided, so f of x divided by g of x, if it turns out to be infinity over infinity or 0 over 0, then we're allowed to do a derivative. So we can do the derivative of the top and the derivative of the bottom. This is not a quotient rule, it's two separate derivatives, and then we could find that limit to the exact same number. And then if it's one of these two things again, we would derive each of them again. So you could have multiple derivatives going on at this point. So our first example that we're going to do is the limit of sine x minus x over x minus 3. So the first thing we need to check is, do we get that indeterminate form? So we're going to come over here and we're going to do sine of 0 minus 0 all over 0 cubed. Well, sine of 0 is 0, so we've got 0 minus 0, and then 0 cubed is 0. So we have 0 over 0, which means we have that indeterminate form, and so now we can use L'Hopital's rule. So to use L'Hopital's rule, we'll do the derivative of just this top portion. So the derivative of sine x would be cosine x, and the derivative of x would be 1. And then the derivative on the bottom would be 3x squared. And then we still keep our limit as x goes to 0. So now we check it again. So we'd have cosine of 0 minus 1 all over 3 times 0 squared. Well, cosine of 0 is 1, and 1 minus 1 is 0. And then 0 squared is 0 times 3 is still 0. Oops, that's not very good. But anyway, so it's indeterminate, so we derive again. Well, the derivative of cosine would be negative sine of x, and the derivative of 1 goes away. And the derivative of 3x squared would be 6x. So once again, keep the limit as x goes to 0. And so we check it again. So negative sine of 0 all over 6 times 0. Well, sine of 0 is 0. With a negative, it'd still be 0. And then 6 times 0 is 0. So yet again, we have an indeterminate form. Now, once again, there are other rules to do this. I'm just demonstrating L'Hopital's rule. So since it is 0 over 0, we'll go through and do a derivative again. The derivative of negative sine x would be negative cosine x. And the derivative of 6x would be 6. And we keep our limit as x goes to infinity. So then we check it again. Negative cosine of 0 over 6. Well, cosine of 0 is 1, with a negative would be negative 1. And then the bottom is still 6. So, hey, we found an answer. The answer to our limit is negative 1/6.